Welcome, guys, to the course Critical Thinking and Practical Reasoning. We are still on Unit 3 Causal Arguments and Session 4 Causation in Populations. The aim of this session is to explain causation in population, state the three kinds of investigations applicable in the relevant difference reasoning and common thread reasoning, and explain the concepts experimental and control groups. Introduction to this session. Causation of population. What is the definition? Given the cause, there is a higher probability that an effect will follow rather than if there were no cause at all. So, given a cause, there's a very likelihood an effect will follow rather than when no cause is given at all. So, when there is no cause, there's no expected effect. But if there is a cause, then there's a high probability that we should expect an effect. Yes, and that is the definition for causation in population. I often identify this with Isaac Newton's first law of motion. A body is at rest or motionless unless it's acted upon. So that is causation in population for you. So since you apply a force or you administer a cause, expect an effect. But if there is no cause, there wouldn't be any effect. Now, there are some key terms you need to take note of. The first is hypothesis, and this is a tentative statement about a causal relationship that is yet to be confirmed by proving or testing. So scientists normally before they start their experiment would have a suspected cause in mind, or if they know from the effect that has happened, they will have a suspected cause in mind. Sometimes from a cause or something that has happened, they will know a possible effect, or they will predict a possible effect that is yet to happen. And that prediction is what is called hypothesis. It remains a prediction until it has been proven or tested. Yes. So the next keyword is target group. This is the larger group from which the control and experimental group is obtained. However, let's look at what experimental group and control group is. The experimental group is a group sampled from the target population to test for a suspected cause or effect. When its members are either exposed or yet to be exposed to the cause or already manifesting a certain effect. The control group, on the other hand, this is the group that is also sampled from the target population. Its members are often not treated exactly as the members of the experimental group, but if they are, then it's to test for a possible reoccurrence of a cause or effect. Now note this. The experimental group and the control group, I think we have basic understanding of them from knowing how scientists work from the laboratory. Sometimes they have this guinea pig that they experiment on. So the guinea pig that has been introduced a certain virus to see its feasibility with the system or adaptability with the system of the animal. That animal or the set of animals that will be introduced to the virus are the experimental group. They are the group that will be experimented on. The other group that won't be touched at all, but when they are done with the experiment, they will compare their biological system to the ones they were exposed to the chemicals. The other group that is untouched is what we are calling control group here. Alright, so with this understanding, let's go ahead to look at the three experiments we'll be conducting today. The first of them is controlled cause to effect experiment. And how does this experiment go? It says this experiment traces the effect from a known cause which is yet to be introduced. So you are tracing the effect and you are tracing it from a cause that you already know, right? Now these are the steps. First, there will be random selection among members of a target group which then will be divided into two. One of the groups will be named as experimental group, whilst the other will be named as control group. The causal factor is then introduced to the experimental group. Meanwhile, the control group will be left untouched even though they share similar characteristics except the cause. 4. The eventual turnout will have the experimental group manifesting signs of the hypothesized effect, and by this we would have organized a control cause to effect experiment. So let's say you practically do it by having a hypothesis to test for whether the female Anopheles mosquito bite causes malaria. So then there will be random selection from a group. Let's say class A is my target group. I select members randomly from class A, and after selecting members randomly, I divide them into two. Let's say I selected 10 randomly. I divide them into two, so 5 each. Then I named first 5 control group. I named the second 5 experimental group. Now, after naming first 5 control group and second 5 experimental group, I now introduce I put them in the same situation where they live in the same kind of apartment, similar conditions. But then I introduce the experimental group who are living in one side of the apartment. I introduce to them the causal factor, that's female Anopheles mosquitoes. But the control group, I don't introduce them to anything. Now, at the end of the period, they realize that members of the experimental group will be showing signs of having malaria, rather than the control group, because control group were not introduced to any female Anopheles mosquitoes, right? So this proves my hypothesis at the end of the day. Now, at the end of the day, when you compare the experimental group to the control group, you realize that you would have done a relevant difference reasoning, because they had all similar instances, but just that one significant thing, which is a cause, was found in one and absent in the control group. So that is control cause to effect experiment. Let's look at the non-experimental cause to effect experiment. This experiment traces the effect from a known cause which has already been exposed to the people in question, the experimental group to be specific. The steps are as follows. A target group will be asked if they have been introduced to a certain cause. 2. Those who affirm the experimental group those who affirm are the experimental group, and those who deny are the control group. Since the experimental group is already exposed to the causal factor or agent, we then monitor both the experimental and control group for some time. 4. Knowing that both experimental and control groups were from the target group with similar characteristics but having the causal factor as a difference, the eventual turnout will have the experimental group manifesting signs of the hypothesized effect, and that will be a relevant difference reasoning. Now let's look at non-experimental effect cause. In this experiment traces the cause from a known effect, unlike the first two, right? So this one and this known effect has already been established, right? So let's look at the experiment here. A target group will be asked if they have members manifesting a particular effect. Those who affirm are the experimental group, and those who deny are the control group. Since the experimental group is already manifesting the effect, we then interview them to identify a suspected cause. The suspected cause is then introduced to the control group. 4. After a period of time, the control group starts exhibiting the same effect which was earlier identified in the experimental group. The control group is manifesting same results as the experimental group, and this implies a common thread reasoning. So that is the non-experimental effect to cause. I'm glad you followed this session and you realized that these causal patterns may result as in 3 different causal experiments. Thank you for following. We will catch each other in the next session. Bye.